Hello everybody, I am going to help you guys with a bit of teaching. This YouTube channel will be specifically for tourism content only, grade 10 tourism for that matter. We are going to work a lot with the Google Drive link that has been emailed to you guys earlier on. We are working first on week 11, term 2, which will cover map work, map terminology, and map symbols. I'm not going to teach everything that you see on your slides, only the more difficult concepts, and a lot of it will be revision from grade 9 geography. So luckily you guys have done some map work before, so I'm going to switch between my workboard and the videos so you guys can see me. So yeah. Please feel free to comment if you want me to teach anything specific, or if there's something you're struggling with. Please ask questions below in the comment section and I will attend to those. Okay, let's get started. So first of all, we need to know what a map is. So a map is, first of all, a visual representation of a section of the Earth's surface. Okay, so we need to know what a map looks like. Normally, things that can be seen on a map is stuff like map symbols. So map symbols helps us to interpret the map and to see what is on the map, and it provides us with a lot of information about a specific area. Okay, then another thing that will always be on a map is a map scale. So the map scale helps us to see how much an area or the picture of the area has been zoomed in. It gives us an understanding of the real size of that area. Okay, so I'm going to go to my workboard now to show you guys an example of a scale. Okay, so up here, we have a scale of 1 to 50,000. So if we have a scale of 1 to 50,000, it means that 1 centimeter on the map represents 50,000 centimeters in reality. Okay. Or 1 centimeter represents 0.5 kilometers. I'm looking exactly over here. Let's choose black. Okay. So 1 centimeter on the map represents 50,000 centimeters in reality. Okay. So this is your common map that you will get. And the one that we work with most often, which is called a topographical map. Okay, a topographical map. This map always has a scale of 1 to 50,000. We can have different types of scales. We can have 1 to 500, for example, and that will simply mean that 1 centimeter represents 500 centimeters in reality. Alright, so that is our scale, and we've mentioned the symbols. So the symbols, I actually want to draw a few for you. So let's say symbols. A few of the symbols that you should be familiar with is definitely something like a hospital. So a hospital, you can think of the general symbol that you always see would be a bit of a block with a cross in the middle. We will need something like national routes. So a route number, this is like your N1 or your R21, so your route number. And that looks something like this. N1. Okay, and there's other couple of symbols that you can look at on your notes. Alright, the next thing that we are going to look at on your notes is distance indicators. So distance indicators helps you to find the distance on a map. It works a little bit different in tourism than what it does in geography. So geography is more complex. So we're going to something a little bit easier, looking at distance indicators. Okay, so first of all, we are going to have, say, point A over there. And here's our route going to point B over there. So we need to calculate basically the distance between A and B, and luckily these are called distance indicators. They write the distance on the line like that. So the numbers given on this line is always given in kilometers. So all you're going to do is simply take 27 plus 30 equals 57 kilometers. So to get from point A to point B would be 57 kilometers. Simple, hey? All right. The next thing we are moving on to is direction. So like you know, we have 4 cardinal points on a compass. Okay, that's a bit of a skew line. Let's fix that. Okay. 4 cardinal points. We have north, east, south, and west. All right, but we do have 16 different directions as indicated on this picture below. So we have north, northeast, northeast over here, east, northeast, then we have east, east, southeast, southeast, south, southeast, south. And so it goes all around. So we have 16 different directions. Now I'm going to show you an example of how to work out direction. So say we have 2 points. We have point A and point B. And your question says that you need to work out the direction from A to B. Okay? So let's just link the 2 points. From A to B. So at your from point, very important, at your from point, you are going to draw a north to south line with your ruler. Okay, and you have, second step is to link your 2 points, which we have done already. Okay, and then what I normally do to make it easier is I draw in a east to west line as well. So I can get a very accurate reading. So if the middle of north and east is over there, but our point A and B lies right between those two, what would that direction be? It would be east, whoops. Let's take that out. It would be east, north, east. Okay, that is your answer for direction. All right, please comment below if you have any questions about the first few things we discussed, the topographical map scale or any other map scale for that reason, direction or the distance indicators or then the symbols. Okay. The next we are moving on to lines of latitude and lines of longitude. Okay, lines of latitude and lines of longitude, they're very important to look at because they give us a lot of information about a map. Okay, if you look at lines of latitude, we know that they run from east to west. They are horizontal lines, meaning they run from side to side. Okay. Another thing we can note is that it divides the Earth into a northern and a southern hemisphere. Okay, lines of latitude helps us with position coordinates. So position coordinates comes in with both lines of latitude and lines of longitude working together. Okay, and then our middle line of latitude, if we look at the Earth, is called the equator. Okay, and this equator can be found at 0 degrees. So if we move up from the equator, we are moving north. If we move down from the equator, we'll be moving south. Okay, let's look at lines of longitude. Lines of longitude run from north to south. They are vertical lines, so they run like this. Okay, they divide the earth into east and west. Okay, these lines of longitude helps us to understand time zones better. And the middle line of longitude, which can be found more or less over there, the earth was there, can be found at 0 degrees, and this line is called the Greenwich meridian. And this is where time zones will come in just now. First, we are going to look at what happens when lines of latitude and lines of longitude intersect. Can you see they're crossing each other? Okay, this helps us to find coordinates on the face of the earth. Any given place, the school, your house, any given place on the earth has position coordinates, and that is only made possible by grid lines, which is lines of latitude and lines of longitude that intersect. So a simple coordinate or position coordinate would look something like this: 23 degrees, 40 minutes, 20 seconds south. And you will have a second set of coordinates, which is 14 degrees, 15 minutes, 10 seconds east. Okay, this is what a simple set of coordinates would look like. Like I said, they help us to find places on the earth. Okay, then we're going to move on to time zones. So this is where our lines of longitude comes in again. Lines of longitude. So if we look at time zones, we all know that we have 24 hours in a day. Okay? And it takes the earth 24 hours to rotate on its own axis. Okay? Now, because there's 24 hours in a day, because of the 24 hours in a day, we know that there's 24 lines of longitude. One line for every hour that passes. If we have 360 degrees, so the reason I'm using 360 degrees is because the earth rotates in a circle, meaning it rotates once around its own axis. So if it takes the earth 360 degrees, to rotate 360 degrees, it takes the earth 24 hours. We are going to say 360 divided by 24 will give us 15. Now this 15 is the degrees that the earth moves in 1 hour. So the earth rotates 15 degrees every hour. Okay. So yeah, I've got a beautiful picture of the earth for us. Simply to help us draw in a few lines. Okay. First of all, let's choose a different color. Maybe some gold. Okay, first we have the line of latitude. We have the middle one, which is called the equator, and the middle line of longitude, which is called the Greenwich meridian. Both of these will be found at 0 degrees. Okay. Now the middle line of longitude, this one, we said is called the Greenwich meridian, but it's also got a very special name, another name for it, and it is called the UTC. Okay, the UTC, which stands for the universal time coordinate. From this universal time coordinate, this is where we calculate all time from, okay? This UTC line runs through England. So England uses the 0 hour time zone. South Africa uses the +2 time zone. Meaning that if the time in England is, let's say, 12 o'clock, and we need to work out what the time in SA would be, we would plus 2 hours to that time to work out what time it would be in South Africa, which would give you 2 o'clock, 1400 hours. Okay, so if we had to say China lies at +8 time zone, and it is 12 o'clock in England, we would say +8 hours to that, which would give us 20, meaning 8 o'clock at night for China. Okay, very important for you to know is this. What UTC stands for, it stands for Universal Time Coordinate. And then there's another very special line, the IDL, that can be found. It's an imaginary line that can be found on the face of the earth. And that line can be found at 180 degrees. Okay, so let's say this line can be found at 180 degrees. So the international date line, say here's our imaginary international date line. On the one side of the line, it would be a certain date. And on the other side of the line, it would be the day before. So as the earth rotates, the date will change when it crosses that specific line. When it crosses the international date line, the date goes on to the next day. Another abbreviation that you guys need to be well aware of is SAST. SAST, and that stands for South African Standard Time. Okay, South African Standard Time. You need to know that SA's line of longitude is the 30-degree east line. Now, if you take this 30-degree and you divide it by 2 hours, you would get 15 degrees, meaning we are the +2 time zone because we pass 2 sections of 15 degrees on the face of the earth in terms of lines of longitude. All right, that is everything covered on your notes briefly. I am still here. If you have any other questions in regards with the work that I just discussed, or please do the activities. If you have questions on the activities, please ask me in the comments below, and I'll try and explain it to you on a video as well as I can. And yes, good luck, and we'll see you on the next episode of Tourism Online.